All right, quadratic systems. We're going to solve some system of equations here, quadratic systems in particular, so there's an x squared in the system. But the first premise I'm going to go at here is every equation is really a system of equations. So if you have the most simplest algebra equation in the world, like x plus 2 is equal to 5, all right, this is really a system of equations. Because this part right here, you could say y equals, and this part right here, you could say y equals. So y equals x plus 2, that would make a line. So there's your first equation in your system, x plus 2. Your second equation would be y equals 5. And then there's your system, a system of equations, two equations working together to find a solution. Even though we know the solution is 3, it's a working together of these two equations to show you that this is the answer. Here's the graph. So x equals 2, yx plus 2 would be 1, 2 up. And let's see, let's go, we'll go to 5 here. 1, 2, 3, 4, 5, right? And we'll go over 1, 2, 3, 4, 5. So there's 3, that's the magic number I'm looking for. And there's 5, and there's 1, there's 1, 3, 5. Okay, so I'm going to go 5, right, is a horizontal line. And then x plus 2 is a line that starts at 2 with a slope of 1. So the question is, what is in common between those two? What number is shared by those two lines? That's the solution to the system, is the common point shared by the two things. Well, look, 3. So x equals 3 is the common point. It makes this true. See, 3 plus 2 would be 5, and then y is already 5. But it solves the answer to this equation up here. So every equation is really a system of equations, and when you solve a system, you're looking for an intersection point, the common point shared by the two equations. So here we go. We're going to solve this first one by graphing, and we're going to use the graphing calculator. So I have my graphing calculator here. I'm going to, that's the last thing I was working on, so I'll go to y equals, clear that out. And we're going to type in x squared minus 2x plus 1, and then x minus 3. All right, so there's my system of equations. And I want to see where they cross. I'm going to hit zoom and 6. So the solution to a system of equations is the intersection of the two equations. Uh-oh. So we know that this curves like this, since it's a parabola, and there's a straight line, and there's space in there, so these never intersect. So the answer to this would be no intersection, or no solution. Those two things never intersect each other. Okay, let's do one where it actually does intersect. So we'll go back to this, x squared plus 3x. And then plus 9, and then go down, and then negative 3x plus 4, enter, x squared plus 3, okay, so now I'm going to hit graph. There's the parabola up there, it's kind of high, yeah, plus 9 would be the y-intercept. Okay, so I think it intersects here, but the way the parabola curves, there should be another intersection point up there. I don't really need to see anything down here, so I'm going to kill all the y values that are negative, and so I'm going to the window key here, and I'm going to go up 25 with a scale of 5. I should be able to see it then. So I'm leaving the, so I hit the window key, I'm leaving the x's alone, 0 to 25, scale of 5. So here's the parabola. Just changing the window so you can see it better. Aha! So you can clearly see there's two intersection points. The calculator will find those for us. We'll go to second and calculate. And we're going to choose number 5, which is intersect. And it says, is this the first curve? Yep. Is that the second curve? Yep. And by saying yep, I'm hitting enter. First curve, second curve, and intersect. negative 7, 1. So negative 7, 1 is one of the solutions to this. So it's negative 7, or negative 1 comma 7 would be my first solution for x, y. And then my next solution is this other point over here. So I guess what's happening here is if I put negative 1 in here, I would get 7 back. And if I put negative 1 here, I'd also get 7 back. So it's the common point between the two. Let's see. Second, calculate, and we're going to go to intersect. And now I have to move over to this intersection point. Is this the first curve? Yes. Second curve? Yes. And guess. You don't even have to be a good guesser. Negative 5, 19. Negative 5, 19. So these 2 points are the solution. They're the common point shared. So that basically what happened is the parabola went like this, and the line came through it like so. And there's a point here and a point here. Those are the common points that make this algebra situation true. All right. The third one we're going to solve algebraically. So this will be, we'll break out the algebra for this, and we're going to use the transitive property to solve this. So, or substitution, whatever you want to say. So this thing here is equal to y, and this thing here is also equal to y. Well, these y values are the same. So since the y values are the same, therefore these two things here have to be the same. So we're going to say x squared plus 9x plus 7 is equal to negative x squared plus 3x plus 7. So now I have a situation where I have a quadratic, and I need to solve the quadratic, and we solve quadratics by setting everything equal to 0. So I'm going to add over x squared. I'm going to subtract over the 3x. I'm going to subtract over the 7. Well, that's cool because the 7's go away. So all this goes away. I get 0. 2x squared, because I have 1 and 1, and then plus 6x equals 0. The 7's cancel out. Well, this here is a perfect example of factoring, and taking out the greatest common factor would be the situation that I would do. So I'm going to take out a 2 and an x, and I get x plus 3 left over, because this times this is this, this times this is that. So I just doing the distributive property backwards. I do 0 product property. 2x is equal to 0. X plus 3 is equal to 0. Now, whatever quadratic you get out of this, you may have to use a quadratic formula to solve it, or you may have to factor it a different way, but this one's just taking out the greatest common factor. I'm going to divide by 2 to get x is 0. That'd be one of the solutions. And I'm going to subtract the 3 over to get x is negative 3. Now, you would think that you're done, but you're not. You have to come up with the solution, the intersection point. So we're looking for the common points shared by these two parabolas. So 0 is easy to plug in, because you plug 0 in here and 0 in there. It's just 7. So 0, 7 is one of the solutions for x and y. And the other solution comes with negative 3. I'm going to put negative 3 in this top equation instead of the bottom one. So negative 3 squared would be 9. A little pencil lead. And then negative 3 goes in there, would be negative 27. And then plus 7. So put these together, it'd be negative 18. Negative 18 plus 7 would be negative 11. So those are the two solutions to this. So the two intersection points of the two parabolas, one parabola is right side up and the other parabola is upside down, so you can kind of envision it. One parabola is right side up, the other one's upside down, and they intersect at two locations. And these are the two locations where they intersect each other. So what's the deal here? The deal is every equation, the most basic equation, is really a system of equations. And when you have a system of equations, you're looking for the intersection of the two equations, or even could be more than two equations, but you're looking for the common points between them. And we can solve them algebraically by setting the two equations equal to each other by using substitution, or you can just straight up graph them and look for the intersection points where the two things intersect each other. and sometimes they don't intersect at all. Then there'd be no solution.